class.
Morning.
So, how are you this morning?
We are fine. Just fine.
Okay, so today we will be looking at chapter 14, sequence and series and geometric series. So before we start this chapter, I would like for us to do the KWL table, which is know, want to know, and learn. So I want you all to write on a piece of paper and tell me what you know about geometric series, what you want to know about geometric series, and what you want to learn about geometric series. So I'll give you 1 minute want to know and what they learn for geometric series. Can I have someone? Fika, can I have?
Yes, I think I know too. What is the geometry series? I want to know too. I want to know how can we know geometry series is. Learn how to complete.
Correct. Okay, so moving on, next slide. Sequence and series learning outcomes. At the end of this topic, students should be able to first calculate the value of A, the first term, R, the common ratio, and Tn, the general term of a geometric sequence from information given about the sequence. Learning outcomes 2. Differentiate between converges and diverges of geometric series. And learning outcomes 3. The third one is solve problems related to the interval of converges and diverges of geometric series. Okay. So, sequence. A sequence is a function where the domain is a set of consecutive positive integers beginning with 1. It cannot be negative, must always be a positive. Also, an infinite sequence is a function having for its domain the set of positive integers. Example 3, 9, 27, 81, 2, 4, 3. Also, an finite sequence is a function having for its domain the set of positive integers 1, 2, 3, 4, 5 until n for some positive integers n. So it must always be positive. Example 2, 5, 10, 17, and 26. Moving on. Series is a sum of sequence. That is the definition for series. So, example here, series can be finite, terminal, or infinite, unending. For an example, 3 plus 9 plus 27 plus 81, 1 plus 3 plus 5 plus 7 plus 9 is a finite series. Infinite series, while for finite series is 0.25 plus 0.5 plus 0.75 plus 1 plus 1.25. Also 2 plus 5 plus 10 plus 17 plus 26. Moving on. Geometric sequence. What is geometric sequence? Can I have someone to read this out aloud? Chelsea.
A geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a constant non-zero real number.
Thank you, Chelsea. So 1, 2, 4, 8, 16 is an example of a geometric sequence with the first term 1 and the common ratio is 2. So, moving on. General term of a geometric sequence. Suppose a geometric sequence has first term A and common ratio R. Then the geometric sequence is A, AR, AR squared, AR cubed, and so on. First term T1 equals to A. Second term T2 equals to AR, which is AR2 minus 1. Third term T3 equals to AR squared, which is AR3 minus 1, and so on. This is the general term. You must know and remember this for this topic, geometric series. So, common ratio is when the second term divided by the first term or the third term divided by the second term. Example, find Tn and T7 for the geometric sequence for the following numbers. So I have a handout. I need you to form 3 groups. One group consists of 2 persons. Can I have 3 groups now? Welcome. So, if you look at the question, it requires you to find Tn and T7 for this geometric sequence. So I'm giving you, as a group, 3 minutes to discuss this. You may how to find Tn. I'm giving you a suggestion here. First, you need to find A. What is A, the first term, and what is R, the common ratio, and then you sub in the value to form the general equation, which is Tn equals to 3/2 times R to the power of n, something like that. You must be able to generate something like that. Work as a team and discuss with each other. Yet, this is the answer. For Tn, this is the answer, which is 3/2 times 1/3 to the power of n minus 1. For T7 is 1/486. So do you manage to get this?
Yes.
Excellent. Moving on. So this is the solution, which is first you need to know what is A and what is R. And then this is how you get Tn by sum in the value of A and R. And then for, and then for Tn, for T7, you sum in the value, N is 7 and A is 3 over 2 while R is 1 over 3 to get the answer. Okay, moving on. Example 9, which is the question 2. Is it question 2 on the sheets given?
Yes.
The nth term Tn of a sequence is given by Tn equals to 25 times 3 to the power 2n minus 3. Show that the sequence is a geometric sequence. Which term of the sequence is 492075? I think this one we should discuss together. So, for the number 1, for the A, this is how the solution is. So you get 9 there. First, you make 2 equations and then you divide equation 2 over 1 and then you will get 9. Are you clear here? Okay, moving on to the B. So, which term of the sequence is 492075? You must sum in this value into Tn and then you do equation like this to find what is n. You log both sides. I think you know this, right? Okay, so it is the 6th term. Moving on. I think we can skip this one. Geometric series. If Sn, definition, if Sn represents the sum of the first n terms of a geometric series with first term A1 and common ratio R, which R cannot be 1, then that is the first formula and also the second formula for R is less than 1, R is bigger than 1. Try to see the position of R. For R is less than 1 is behind the 1. For R is bigger than 1 is in front of the 1. So try to memorize this somehow because you will need this. So the relation between Tn and Sn is Tn equals to Sn minus Sn negative 1 minus 1. Okay. This is the concept for this thing. Moving on. Example. If I'm not mistaken, this is example 4 in the sheet given. Am I right?
Yeah.
Find the number of terms in the geometric series 1 over 2 plus 1 plus 2 plus until 1 to 8, and hence find the sum of the series. So I think you can do this in 3 minutes with your group mates. first term A, and we must know what is the common ratio. And then we sub into this to get this, to know what is n. The formula for this is, sorry, Tn is equals to ARn minus 1. So, the 1 to 8, we must sub into just Tn, and the A value is 1 over 2, we sub into A, and R value is 2, we sub in. And then we do solving linear question like that, algebraic, to find what is n. N is 9. So I think you can do this because this is like the most easy question, the most easy part of this question. Okay, so for the sum of the series, we must know either A is bigger than 1 or A is less than 1. What is A in this question?
Half. 1 over 2.
So 1 over 2 is less than 1. Less than 1 means we use the formula whereby the R is behind the 1. So you sub in the value and you will get 511 over 2. Are you clear on this?
Yes.
Example 12. So this is example 5 in the sheets I gave you. In a geometric sequence, the sum of the first two terms is 4 and the sum of the next two terms is 64. Find the common ratio. The sum of the first two terms is 4, meaning to say T1 plus T2 equals to 4, while so A plus AR equals to 4. This is the first equation. And then 3, 4 plus 3, T3 plus 3, 4 equals to 64, which is the sum of the next two terms. And then we get the second equation. So we divide equation 2 with equation 1, and we get this. And R is equals to 4, plus minus 4. But since R must be positive, so the answer is positive 4. Okay, moving on. Sum of an infinite geometric series. If A1 plus A2R, if A1 plus A1R plus A1R squared plus dot 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 is an infinite geometric series with R modulus less than 1, then the sum of S of all the terms of this series is given by S equals to A1 over 1 minus R. For an example, given the infinite geometric series, this is a series. 1 is what?
A.
R is what?
Half. No. 3.
Yes.
2. Half.
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 So, we use this and get this. As n approach infinite, it becomes 0. Something like that. So, sum to infinity. Do you get this question? This example?
Yes.
Okay, nice. Moving on. Now consider the geometric series as shown. The sum of the first n terms for R less than 1 can be written as this. So do you understand this?
Yes.
Basically, you just sub in the value from the series there, and then you split the fraction.
Yes.
If R is within this range, then Rn is approaching 0 as n approaching infinite. Like this. The example, I think we can skip this. Example also, I think we can skip this because this all is just the basic one, which is you can do it at home. Okay, this one, try to find it in the sheets given. I think it's somewhere between question 7 or question 8. Find a rational number that corresponds to 1.0102. So as a group, try to think. I will give guidance. So this is, you can do it like this. You can split the number 1 plus that, plus that, plus that, and so on. Whereby A equals to this and R equals to this. While S infinite is 17 over 1665, and then, I'm sorry, you plus 1 with this to get this. Any question regarding this question, this example? No question? Okay, moving on to the next slide. Which is the learning outcomes for this one is differentiate between convergence and divergence of geometric series and solve problems related to interval of convergence and divergence of geometric series. Okay, so this is a recap of what we have done in the first slide. A sequence is an ordered list of objects. A function whose domain is a set of integers. So this is it. We're finding patterns. Describe a pattern for each sequence. This is what we have done. So we'll just go through this. Write a formula for the n term. So if you see this, we first must know what is A, what is R. Like this. This is the pattern, and this is the pattern for that one, and this is the pattern for that one. Okay, moving on. Write the first 5 terms for an equals to n minus 1 over n. So the first five terms is you sub in from 1 until 5 to the n value. So you will get 0, 1 over 2, 2 over 3, and so on. Do you get how do we get this series? I think you get. You can do it like that, or on a number line, or as a function. Okay. So write the terms for an equals to 3. So when you find question like this, the terms are 3, 3, 3 until it remains 3. Because it doesn't have any unknown that we can replace the value in it. Okay, so this is it. The sequence converge to 3. Okay, so y equals to L is a horizontal asymptote when sequence converge to L. So, horizontal asymptote, this is an asymptote. Try to digest this diagram. Any question regarding this diagram? Any question?
No.
Okay, it seems like you've done your homework regarding this chapter. Okay, next. A sequence that diverge using this formula. So keep this in mind. An equals to -1 to the power n plus 1 in the bracket n minus 1 over n. That is the general formula. And then this is how you can generate as a number line or as a function. So sequence. I think we can skip this because we have done this previously. Oh, I think I need to highlight does the sequence converge? If so, find the value. So write the first 5 terms of the sequence. So using this, we sub in the value 1 until you get the 5th term. And then as it approaches infinite, it will become 0. Also, this, you sub in the value, limit as it approach n as limit n as it approach limit does not exist. Because when you sub in the value, it doesn't exist. The sequence converge to 0, horizontal to 0, and then the sequence diverge because it does not exist, because limit does not exist. Infinite series, that's like that, represent the sum of the terms in a sequence. We want to know if the series converge to a single value. There is a finite sum, like this one, the one I explained just now, the tree. It is somehow related to that. The series diverge because Sn equals to n. Not that the sequence 1 converge. Example, this. Starting from there, partial sum of this. We start from here, S1 is equals to 1 over 2, S2, 2 over 3, 3 over 4, and so on. If the sequence of partial sums converge, the series converge, and it will become something like this. Do you understand this?
Yes.
Okay, finding sums like that, you just need to sub in the value. Can use partial fractions to rewrite. So when you get like this, you must first make it into partial fractions, and then it will make your life easier if you know how to make new partial fractions. So it will go like that and like that. Any question regarding this?
No.
Okay. The partial sums of the series, it goes like this. So take time to digest this. Okay, geometric series like that. We just sub in the value n equals to 1, n equals to 2, n equals to 3, n equals to 4. Okay, so find the common ratio for this. So how do we find the common ratio? We can find the common ratio Okay, so I'm sorry. Okay, so do you get the idea of finding the common ratio for these two questions? Yes.
Yes.
Okay, moving on to the next slide. The sum of a geometric series. Something like that. First, you do it like that. And then you subtract. And then we get this. If r is less than 1, as Rn approach 0, as n approach infinite.
Yes.
So, any question regarding this?
No.
Fika, can you understand this?
Yeah.
Fifi, can you understand this?
Yes.
Seems like the students are smart. So geometric series converge to Sn equals to a over 1 minus r if modulus r is less than 1. If r is bigger than 1, the geometric series diverge. So it's a geometric series where a equals to first term and r common ratio, right, using series notation. So how do you write this into something like this? This is an example I gave, and I think you can generate something like this from this too, right? So give it a try first in your group. Yes, you can try in front if you want. Which one do you want to try?
Number 2.
Okay.
Okay, this from first question too. I think like this. Like for 1. So
Yes.
ARn-1. So formula kita kena cari kena A lah kan?
Yes.
So A dia ialah
3 over 5.
3 over 5. And R dia someone can help me to try the R dia?
R is equal to
R negative 12 over 5 over 3.
4 over 5.
What?
4 over 5.
4 over 5.
Negative.
So I think
Negative.
negative.
Yes.
Negative 4 over 5 and minus 1. Maybe.
Okay.
Am I right?
But you forgot the infinite and the n
Yeah.
equals to 1.
Right.
Yes. So nice try, Fika. Give a round of applause to Fika for trying. Okay. So if Pika can do this, I think this you can also do at home. So this is as a homework for you.
Yeah.
So this is the answer. Pika, nice job. Okay, find the sum of a geometric series where a equals to first term and r common ratio. So something like that.
Yeah.
So if this is the example for that one, and this is the example for that one, who wants to try the third one? Chelsea?
Yes. I would like to try the third one. Firstly, we know that this is A. This is the value of A, and this is the value of the common ratio. Yeah, R. So, according to the formula, it's A over 1 minus R. Hence, we just fill in the formula. Since A is 2 over 3, and R is 2, that's the formula. It's like this. Somebody, 1 minus 2 minus 2 over 3.
Yeah.
Negative 2.
Then the answer is the series diverge. So that is a good answer from Chelsea. Now we will be seeing, since R is less than 1, the series converge. Remember the thing that I told you before, if it is less than 1, it converges. If it is bigger than 2, than 1, it diverges. Something like that. So the series converge, the series converge, the series diverge. Okay, moving on. Exercise, this is exercise 9 of 10 if I'm not mistaken. Determine if each of the following is converged or diverged. Give its sum. Number 1. Number 2. Okay, so you can do this. I think this is within your within the sheets I gave. Okay. Number 2? 10. Okay. Next slide. Repeating decimals, geometric series. The thing that we have learned before, the decimal. Somehow is something like this. And A is 8 over 10 square, while R is 1 over 10 square. So we just sub in the value into this equation and we will get this. So the final answer, if you use calculator, you will get this. The repeating decimal is equivalent to 8 over 990. So series known to converge or diverge. A geometric series with modulus R less than 1 converge. A repeating decimal converge. A necessary condition for convergence. Limit as n goes to infinity for nth term in sequence is 0. So when you sub in the value, it equals to 0, then it converges. Something like that. So nth term test for divergence. If the limit as n goes to infinity for the nth term is not 0, the series diverges. So if it is equals to 0, it converges. If it's not equals to 0, it okay. Power series, a topic under convergence and divergence. So infinite polynomial in X. If you can see, this is the basic, this is the general formula. It's a power series centered at X equals to 0 and something like this. You sub in the value whereby A is the first term. Wait, I'm sorry, A is not the first term, whereby A is equals to X. So if it is centered at 0, it will be 0. If it's centered at A, it will be A. I'm sorry for the mistakes just now. So another example, if it's centered at 0, if it's centered at X minus 1, so geometric power series. A1 and R is X. So you, with the formula, with the general formula like this and this, you generate this, and this via this formula. Do you get it?
Yes.
This is the graph for fx equals to 1 over 1 minus x and 4 of its polynomial approximations. 1, 2, 3, 4. So I think you can digest this graph for a while. Can I move on?
Sure.
Yes.
Convergence of the power series. There are three possibilities. One, there is a positive number r such that the series diverge for x modulus x minus 1 is bigger than r, but converges for the modulus x minus a lesser than r. The series may or may not converge at the endpoints x equals to a minus r and x equals to a plus r. It will become like this in the number line. The series converge for every x, and it will become like this. So see the difference?
Yeah.
The series converge at x equals to a and diverge elsewhere. So it becomes like this. So try to understand these three conditions regarding convergence of a power series. Next slide. What is the interval of convergence? So based on this, since r equals to x, the series converge modulus x less than 1 or this range, whereby -1, x, 1. In interval notation, it is in the bracket n, -1, 1. Test endpoints of this value into that, and then you will get the series diverge, Okay, so find the function. So can someone try to understand this? Fifi, can you read this out aloud?
1 over 3 to the power of n multiplied by x plus 1 to the power of n.
So, I mean this whole thing, but it's okay, Fifi, it's okay. So, if you see this, you must first find the first term and then common ratio. And then you sub in into this formula to get this. Okay? So find the radius of convergence, whereby you use r as the unknown you search for, and then it will become like this.
Okay.
Any question regarding this?
No.
Find the interval of convergence for x minus 2. So we will go through this very fast. You just sub in the value of x. This is the general formula. It's sub in the -2. Then you will get this, and you will get this. I think you can get this right, because -2 plus 1 is -1, and then you will get something like this, and you will get something like this. It is the same for this one. You just sub in the value. With r lesser than 1, it converges, but like that. Finding interval of convergence. So this is the general formula you must know. Use the ratio test to find this. So you will get this when x is lesser than 1, r equals to 1, and this is the domain, whereby -1, 1. For x equals to 1, it equals to 0, harmonic series diverge. For x equals to -1, alternating harmonic series converge. So the interval of conversion is using this kind of bracket. You must know the difference between this and this. So -1, 1. Are you clear on this?
Yes.
Yes, do this exercise. I believe this is within the sheets I gave.
No.
Easy.
There's only
Oh,
one.
yes.
Ah. So I think you can take picture of this and solve this at home.
Sure. I didn't bring my smartphone.
Okay, so I see. This is the solution for this question. I'm sorry.
So-
So basically, yes.
Can you go back a few slides? And one more. Yes. Can I try to understand what I can I try to explain what I understand and
Okay.
ask you whether if it's right or not? Since the A is 1 and the R is -1/g x plus 1, how do we know? We just need to basically masukkan, substitute it into the formula, and hence the formula is 1 minus AR power 1 minus AR power 2, right? Can I go in front?
Yes, yes, yes.
Can I borrow? Yeah. You can correct me, sir.
Yes.
The formula is A minus AR power 1 minus AR power 2
Yes.
minus so on. It can go up until infinity. And since the A is 1, and the formula states that it's A minus AR power 1, and the R is given whereby R is minus 1/g x plus 1, hence why we get it as positive, and A is 1 times 1/g x plus 1, that is why we get this. Is it, sir? Am I right?
Yes.
This is just based on my understanding, and it goes all the way until infinity. Is it right, sir?
Yes.
Ah.
So basically, what question do you want?
I wanted to ask, how do we get this? When we have this, everything up there, how do we get this?
This is the sum.
I think substitute n when n equal to 0, and when n to 0 on 1 equal to 0 is 1,
Huh?
right? So and then negative 1 when kita substitute n equal to 1, and kita will get 1/3 x plus 1. But because we substitute all the n is 1, this is accounting 0, 1, 2, 3. I think, right?
Yeah, I understand. I
Yes.
understand. I
Thank
didn't
you.
hear it. Oh, can you please explain again?
No. Can I?
Okay, Shafika.
No. I think based from the list, the punya list which is right? N equal to 0. Okay. Why did we get 1? When we substitute n equal to 0, n equal to 0, so to set to 0, x plus 1, 0, so equal to, set n equal to 0 equal to 1, right? And then 1/3 x plus 1. So kita substitute is 1, 1, 1, and kita akan dapat negative 1/3 x plus 1. And then if we substitute to 1/3/2,
And you will get this and so on. Thank you, Fika.
Yeah.
You get this, Chelsea.
Yes, I get it.
Okay, moving on. So this is what we studied, and this is the end of the slide. So I believe that every lesson there will be a quiz by the end of it. So prepare to answer the quiz I gave.
Sure.
So This is the test. This is the test. This is the test. This is the test. So you can answer it in 5 minutes. And we will do a Kahoot of everyone open Kahoot. And this is the pin. So this Kahoot will be the summary for what we have learned today. And first place will get present for me. So try your best to score first place.
Sir, I would like to share with my friend.
Yes,
My
you
phone is broken.
Okay.
Hence I didn't know. My friend is so unfair.
everybody entered?
Yeah.
1, 2, 3.
Player one.
One more player.
Who is player one?
Since two person doesn't have their phone with them,
Sir, may I borrow your phone?
cannot. Okay, so we will start the game since everybody is in. Okay, question 1. True or false? Wow. Okay, next. Player 2. Yes. Player 2 still remains at the top. Pocoyo.
I'm so sorry. Pocoyo? I think this Pocoyo.
Next. Yes.
Pocoyo so smart.
Okay.
If you put my name, Pocoyo, you can Are you sure Pocoyo? Yes. Oh my god. My You see Pocoyo. Sir, Pocoyo getting good, sir.
Second last question.
I think Pocoyo drop one more. Sir, Pocoyo number 2, sir.
Okay, last question.
Confirm.
Number 1, 7 out of 10.
Okay, Pocoyo last, sir.
Oh!
Pocoyo second place, sir.
And the first place is Z.
Please, Z, man.
Who is Z? Okay, so coming back to get the present.
What letter? I got kitchen.
Okay, so this is the present. Share because
Thank you.
okay, that's all for today. Thank you.
Thank you, sir.